Hello everyone. Myself, Professor Dr. Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla. Now, in this lecture, we will discuss one of the important aspects of probability, that is the random variable. Now, coming to the background of this lecture series, I have been requested by many of my students to prepare video lecture for them for the benefits of the students. I too motivated to prepare a series of lectures on probability and statistics. In this lecture, I will discuss the random variables, assuming that the basic things is known to you, what is a sample space, sample point, mutually exclusive event, and so on. Later on, I will also discuss these things during my preliminary lectures, but this random variable is one of the important topic, so let me to discuss the random variable in this lecture. So now this coming to the definition of random variable. What is a random variable, right? Coming to a random variable, this random variable is, we may denote it by capital X, or if you like, you may denote it by a function f, is a real valued function. The outcome of the function is a real number, right? So we write it. It is a function. The domain is the sample space, right? And the range is the set of the real number. Range is the subset of, you may take any subset, right? You may take any subset as the range. Such that, so in this sample space, there are sample points, the elements of the sample space. Now for each element, as I take an element of the sample space, they are associate a real number, right? This real number R. Now this real number R, this R may be positive or negative, right? May be positive or negative or zero, no issue. Such that each sample point is associated with a real number, right? And this outcome is purely depend upon the chance, right? Suppose we roll a die, then what will happen? In rolling a die, 1 or 2 or 3, 4, 5, 6, anything may come. In first roll, if I get 6, in second roll, I may get again a 6. It may be 1, 2, 3, 4, 5 or 6, and we can say it purely depend upon the chance. That's why a random variable is also known as a stochastic variable or a chance variable, right? Is a chance variable or a stochastic variable. Now, if I explain it through an example, then your idea will clear. Now, coming to an example, suppose in tossing a coin twice, the random variable x be the difference of, what is the random variable here? The difference of head and tail in an outcome, or trial, you say, in an outcome. So here, what is the sample space here? Since you are tossing a coin 2 times, the sample space is like this: head, tail, head, tail. Is not it? Right? In first trial it may head, in second trial it may again head. First trial it may head, second it may tail. In that way, this is my sample space. So what is the cardinality of the sample space here? Is my 4. Now each sample point here, right? Now this is a sample point, this is my S1 say. This is a sample point, my S2 say. This is a sample point, my S3. This is a sample point, my S4. As I have told you, each sample point, right? So now coming to this, in head for S1, what is the difference between head and tail? How many heads? 2 heads. How many tails? No tail, right? So it is my 2, right? So here the moment I say what is x associated with the samples point S1, it is my 2. Similarly, for this I say what is the random variable associated with S2? It is the difference between head and tail. How many head? Head is 1. Tail, how many tail? Tail is 1 and it is 0. And it is also the same thing here. And it is also my same thing as x of S3, right? X of S3. Then coming to x of S4. Here how many heads? No head. And how many tail? 2 tail. it is equal to minus 2, right? So now what is my random variable here? So I may write the random variable x as, right, it is a set consisting of the real number, right? In ascending order, you say first we write suppose minus 2, and then I write as 0, right? 0, 0. But repeated elements are counted once, taken once in a set. Repeated elements are taken once, right? And 2. So this is my random variable here, right? This is my random variable. Now coming to the probability distribution out of this random variable. What is the probability distribution? Probability distribution out of this random variable. You see, if I ask what is probability of x is equal to minus 2. So what is my event set here? It is my probability of, what is the event? For x is equal to minus 2, my event is only this, right? The event here is tt, right? So this is, so what is the probability here? So cardinality of, I suppose call it my event 1. So it is probability of E1 divided the cardinality of E1 divided by cardinality of the sample space. So this is this cardinality of this set is here only 1, and the sample space cardinality, as you have told here, it is 4. So it is 1 by 4. So now if the moment I ask you what is probability of x is equal to 0, means what is the event here? The event here is you may get one head, one tail, or you may get one tail and one head. Is not it? Right? So what is the probability here? The cardinality of this is 2, and the cardinality of the sample space is 4, and this is my 1 by 4. Likewise, if I ask what is the probability of x is equal to your 2 here, right? Means probability of getting here all head, not tail, right? All head. So it is also a singleton set, and the cardinality of the set having one element is 1. The sample space is 4. It is here 1 by 4. So you see here, this is the probability we get, and this probability, as per the axioms of probability, right? It has to greater than equal to 0, right? This, you know, the probability of any event lie between 0 and 1, right? Probability of any event lies in between 0 and 1. Probability of the sample space is 1. However, this random variables here, right? This is a real number. This may positive or negative, right? Here minus 2. It may positive or negative, but the outcome is positive or negative. But the outcome here is the probability is 0. Now the random variable together with the probability distribution is usually given by a distribution table. So the random variable together with x, together with the probability function, is given in a probability distribution table. Distribution table as follows, right? As follows. So that is my x and my p of x, right? So x is the random variable here, minus 2, 0, and it is my 2. For minus 2 it is my 1 by 4, and it is this is your 2. So for 0 it is your 1 by 2, and it is your 1 by 4, right? So this is the probability distribution, right? I may say this is my x1, this is my x2, I may say this is my x3, and this is my p1, this is my p2, this is my p3. You know, the sum of the probability, sum of the pi, or I mean denote it sum of the fi, right? Then it must be always 1. You know, the sum of the probability is 1, right? That means, and this random variable, right? All these events here, if we see this E1, E2 and E3 events, this E1, E2 and E3, these events are exhaustive, right? These events are exhaustive, right? These events are exhaustive. So random variable is such that the events are exhaustive, and we get the sum of the probability is 1 and individual probability is greater than is equal to 0, right? So this is a definition of the random variable. If we talk about another example, suppose in tossing a coin three times, right? Let the random variable x be the number of heads in an outcome, number of heads in an outcome. Then what is the sample space here? The sample space here is head, two head, one tail, head, tail, head, here tail, head, and likewise two tail, one head, then tail, head, tail, here head, tail, and all tail, right? So this is my sample space. Now for this, how many heads here? So x is equal to 3, and here how many heads here? And here x is equal to here 2. How many heads? 2 heads. And here how many heads? 1 head. And here how many head? No head, right? So that means what is my random variable here? Random variable are the real numbers. What are the real numbers here? The random variable here is my 0, 1, 2 and 3, right? If we think of the distribution table here, what is the distribution table? The distribution table here is here x, here f, right? Individual probability, and here it is 0, 1, 2, 3. For 0, all tail means only single element. So what is the cardinality? It is 1, but the cardinality of the sample space is 2 to the power 3 is 8. Okay, 8. So in tossing S, what is the cardinality of the sample space here? The cardinality of the sample space is 8 here. Now for one head, so the events consisting of these 3 elements. So cardinality of the event is 3. Cardinality of the sample space is 8. Then coming to 2 heads, how many elements in this event here? So here we are getting again 3 by 8. And coming to x is equal to 3. So we are getting the event set consists of only 1 element. So it is here 1 by 8. You see, now if you sum of them, right? If you sum of the probability, what is the probability now? The sum of the probability here fi, if you call it fi or p of xi, now this is here 1. It's not it. 1 by 8, 3 by 8, 3 by 8, 1 by 8, sum it 1. And individual fi is greater than 0 here, right? Greater than equal to 0, maybe equal 0, maybe here. So for all I. So this is the definition of the random variable. All of you clear? So now coming to the types of random variable. How many types of random variables are there? Types of random variable. Random variable are basically 2 types. One is discrete random variable. Other one is continuous random variable. One is discrete random variable, other one is continuous random variable. What is a discrete random variable? The above 2 examples what we discussed here, this is a discrete random variable. In discrete random variable, what will happen? The sample points are occurred, distinguished sample points are obtained, and these are all finite number of sample points, right? So A random variable basically for a discrete type random variable. So here the sample points are occurred finite number of and distinguishable. Maybe it can be extended to infinity, but it is countable, right? So this type of random variable. In continuous random variable, right, you cannot, the points, sample points cannot occur in a distinguished manner, right? There are infinitely many sample points. For example, if I say you record the rainfall, you record the hardness of steel, right? If you say record the rainfall here, you cannot get it distinguished fashion, right? And over a time, this mm of rain has been recorded. So here, with the probability function are specified under certain intervals, right? Under certain intervals here. Under certain intervals here. C less than x less than d likewise. So it is some f1, it is some f2. That means the continuous random variable are in fact infinitely many, but the points are not distinguishable, right? Okay. But in discrete random variable, these are come a finite number of sample points and the points are distinguishable. In fact, coming to, if I ask you within 0 to 1, right, you find all real numbers. Can you distinguish them? There are infinitely many, but we cannot say what real number will come after what. Okay, so these occurred, the real numbers occurred here in a continuous fashion. Similarly, if the sample points occurred in a continuous fashion, then it is called a continuous random variable. Let me to tell you one more example of the definitions in individual cases. What is a discrete random variable? What is a discrete random variable? Discrete random variable. A random variable, capital X, is said to be of discrete type. Discrete type if it has finitely many sample points. Sample points Xi's, and each sample point associated with a probability function, probability pi or fi, such that, and these are called the probability mass function. These are called the probability mass function, right? Probability mass function. Probability mass function. In short, PMF, probability mass function. For a discrete random variable, we have the probability mass function PMF, such that, and the probability mass function are such that it has to satisfy the followings. Satisfy: 1, individual probability is non-negative greater than or equal to 0. Second, the sum of the probability is 1, as we have seen earlier, right? So once these two holds, right, and it's occur in a discrete fashion one after another, in a discrete x1, x2, xn, so on, then it is a discrete random variable. And sometimes maybe x1, x2, xn, it may continue up to infinity, but it is countable. If I ask the set of natural number 1, 2, 3, it is infinitely many, but it occurred in a discrete fashion. Set of real number, it occurred in a continuous fashion, right? The above two examples what we have discussed are of discrete random variable. Now comes to a continuous random variable. Continuous random variable. A random variable capital X is said to be of continuous type. Is said to be of continuous type if it occurs in a continuous fashion if it occurs continuously. In fact, includes infinitely many points, many non-distinguishable points, right, over an interval, over an interval, over an interval, and for each sample point, x, they are associated a probability function p of x or f of x, we called PDF, probability density function, such that it satisfy one individual probability function is positive, fx greater than equal to 0 for all x, and secondly, we cannot get the sum here, we integrate it over the entire interval, right, fx dx each one. This fx here, the probability curve, and the area here under the probability curve in the infinite region is 1. So it is a continuous version of, we cannot get the sum over here, so we integrate it over the whole interval, this one, it has to satisfy this. This is a continuous random variable, right? For example, if I ask you, let x be a random variable with probability density function, right, fx is equal to sum e to the power minus x positive and 0 x negative. How do you know that? Since this is interval here, right, can you not say that this is 0 less than equal to x less than infinity? Can you not say this is minus infinity less than x less than 0 less than x, sorry, minus infinity less than x less than 0, right? So this is an interval here, right? This interval here is 0 to infinite interval, and this interval here is minus infinity 0 to interval. So here it cannot be at a single point you find, it is rather in an interval, right? So now you see e to the power minus x is positive for any x. So you see fx is positive here for any x, right? And you get the integral of fx, it should be here 1, right? What should be the integral of fx here? So now the integral here is, so this is equal to 0 to infinity, because in the negative interval it is 0, e to the power minus x dx. If you integrate it, it is e to the power minus x, the integration is minus e to the power minus x 0 to infinity. This is e to the power minus infinity is 0, e to the power 0 is 1, so it is 1. So this is a continuous probability distribution here, right? Sum of the probability is 1, condition I is satisfied and condition 2i is satisfied, is not it? So this is a continuous probability distribution. Clear? Now continuous random variable case. Now coming to the distribution function, another important aspect is the distribution function. What is the distribution function? Right, let x be a random variable. It may be of discrete type or continuous type. Let x be a random variable. Then the distribution function f of x at small x, you say, right? The distribution of fx, the distribution of fx at small x, right? Then the distribution of fx at x, right? The distribution of fx at x, we denote it the capital Fx, right? The distribution function is denoted as capital Fx. Let x be a random variable, then the distribution of this function at the point x is denoted by f of x equal to x is given by probability of x less than is equal to x. Now we may discuss it under two cases, right? One is for discrete case. For discrete case, what will happen? For discrete case, here f of x is equal to x is probability of x less than is equal to x means up to x we add the probability functions, okay? We add the probability functions up to x, we will add it, right? But the moment it is a continuous distribution, now if it is a continuous random variable, if it is of continuous type, then f of x at the point x is probability of x up to x. So what does it mean? From starting point up to infinity, up to x, up to this point, whatever this is given, we'll integrate the density function here. We integrate the density function here, right? We integrate the density function here. For this sake, I can have some remark here. You see, if I ask you, what is probability of A less than X less than B, right? What does it mean? It means you have to integrate it from A to B, fx dx, right? If it is in the sense of the continuous version here, we'll integrate it, means the area under the probability curve fx between A and B. Clear? We may write it in distribution sense, it is fb minus fa. If I ask here, in view of the continuous, if you are asked what is probability of x less than is equal to A, means it is nothing but the distribution, means from beginning up to A you integrate it, okay. If I ask what is probability of x greater than A, if we write greater than A is same thing as probability of x greater than equal to, because in continuous case the probability at a single point doesn't matter, right? So this is equal to, means A to infinity, starting from A to last fx dx, or we may write it 1 minus p of the reverse, the complement here, I say x less than A, means I can say 1 minus integral minus infinity to A fx dx, right? So here one more important thing I can say here is probability of A less than x less than B is same thing as probability of A less than equal to x less than equal to B, which is again same thing as probability of A less than x less than equal to B, or probability of A less than equal to x less than B. Means the important to note here that in continuous case, by saying probability at a single point single point is not defined, undefined, is meaningless. Is meaningless, rather I can say meaningless, right? Because it has to be specified in a interval, right? So that's why we may write less than, we may write less than equal to, no issue. If I ask you what is f of minus infinity, so what does it mean? It means minus infinity to infinity, minus infinity f dx. Is it not yet 0? Right? If I ask what is f of plus infinity, that means the distribution at plus infinity. It is minus infinity to plus infinity f dx. Is it not here 1? So this is the interpretation of the continuous random variable. Now let me to solve some examples, then your idea will clear. Coming to one example. Now coming to the example, suppose the discrete cases. Let x be a random variable with the following probability distributions. When x 0, 1, 2, 3, 4, 5, 6, the probability functions are k, 3k, 5k, 7k, 9k, 11k and 13k. You are asked to find what is your k, right? For your k, you know the sum of the probability is 1, is not it? Sum of fi is equal to 1. If you add them, k plus 3k plus 5k, you add them, so it will give you 49k is equal to 1. So this implies your k is equal to your 1 by 49. K is equal to 1 by 49. Again p less than 4. Less than 4 means you add here p1 plus p2 plus p3. Okay. Less than 4. 4 is not included. Also p0 plus. And here if you add it, right, k, 3k, 5k, 7k, 7 plus 3, 10, 16k, right, it is here 16k. So this is equal to 16k, means 16 by 49. If you think of k greater than 5, also equal to is there. Here equal to matters, means it is 5 plus 6, right? It is 5 means 11k plus 13k, right? Means it is 3 to 6. 3 is not included, right? Means it is f4 plus f5 plus f6. Means you add 4, 5, 6. Means this is your k into 9 plus 11 plus 13. K into 9 plus 11 plus 13. Right? So this is your 33k. 33k is here 33 by 49. Okay. So it is a discrete case. Coming to an example. If x has a probability function, fx is given like this. And you see, the points seems to be infinitely many, right? But the distinguishable points, right? It is a discrete distributions. To guarantee that it is a discrete distribution, we must see that sum of the probability is 1. If you think of the sum of the probability, right? So if it is your x is 0, 1, 2, 3, so on. What is your fx? Fx is 1 by k by 2 to the power 0. It is k. It is k by 2. It is k by 2 square. It is k by, it is here k by 2 to the power 3 and so on. If you add them, summation of f, you add them, k taken out, it is 1 plus half plus 1 by 2 square, right, and so on, and this is your 1. Sum of the probability is 1, right? If you add it, it is a GP series. Otherwise you have here 1 by 1 minus x is 1 plus x square, so on. So this is 1 by x is your half, 1 minus half. This is equal to your 1. If you simplify it, this implies k by 1 by 2 is equal to your k by 1 by 1 by 2 is equal to your 1. So that means your 2k is equal to your 1. Implies your k is equal to your half, right? K k is equal to your half. Now next it is asked, the value of k is now find. Now if it is asked p of x greater than equal to 4, means are you going to add from 4, 5, 6 up to infinity? You just apply its complement. So p of x greater than equal to 4 will be 1 minus p of x less than equal to 3. 4 will not be included here. So then it will be, you just add it here. So this is 1 minus here k up to 3, k plus k by 2 plus k by 4 plus k by 8, and you find the answer then. Okay. It will be here 1 by 16. It will be here 1 by 16. Coming to one more example. A coin is tossed repeatedly until a head turns off. Find the probability distribution and prove that it is a discrete type distribution. Right? Here it says a coin is tossed until a head turns off. Means if you find head in first trial, you stop. Otherwise, suppose you get tail in first trial, head in second, then you stop. Suppose in first two trial you get tail, in third trial you get head, then you stop. And you continue this process till you get a head. Suppose in n-1th trial you get t up to n-1 and you get head, then you will stop. And it may also continue. Right? So this in tossing a coin is usually a fair coin. Means probability of getting a head is your half. Probability of getting a tail is also your half. So what is the probability function here? The probability function, it is your half. It is half square, 1 by 2 square, 1 by 2 cube, so on. It is your 1 by 2 to the power n. Now, if you think of the sum of the probability, what is the sum of the probability? It is 1 by 2 taken common. You add it. 1 plus half plus 1 by 2 square plus on. As I have told you, it is 1 by 2. It is 1 by 1 minus x, 1 by 1 minus half, right? So it is here 1. So this is guaranteed that it is a case of the discrete type distribution. It is a case of the discrete type distributions. Now coming to some example of continuous type, right? Continuous type. Suppose you are given x be a random variable with probability function f of x is equal to like this. Here an interval is given, -3 less than x less than 3, right? Find k. So to find k, what you have to do? You have to integrate it. -infinity to infinity, f dx is equal to 1. But here only -3 to 3 will work. So -3 to 3, here f value is kx square dx is equal to 1. If you simplify it, this is even function. So twice 0 to 3, k x square dx is equal to 1. So that means 2k, here x cube by 3, right? 0 to 3 is here 1. Okay. If you simplify it, you will get, if you simplify it, this implies here 2k into 9 is equal to 1. So k is equal to here 1 by 8, right? K is equal to here 1 by 8. Similarly, if it is asked, then it is nothing but integral 1 to 2 f dx. You see, 1 and 2 are within this, so the function kx square will work here, right? So this is 1 to 2, 1 by 18, it is here x square dx. For x greater than 1, means 1 is here, means it will up to 3. It is 1 to 3 k x square dx, and you can simplify it. Likewise, coming to one more example, right? Let x be the thickness of washers a machine turns out. Assume that x has the density like this. F of x is kx if the washer turns out within this range mm and 0 otherwise. Find the value of k, and next, what is the probability that a washer will have thickness between this? right? So here for your k, how to find k? Means integral minus infinity to infinity f dx is equal to 1. But here it is only permissible here. So here minus infinity to 1.9 plus 1.9 to 2.1 plus 2.1 to infinity f dx is equal to here 1. Now here this function is 0. Here the function is 0 because otherwise case. So that means 1.9 to 2.1. The value of a is kx dx is equal to here 1. If you simplify it, so this implies you solve it to get the value of k is 2.5. Now coming to this question, here it is asked probability of 1.95 less than x less than 2.05. Okay, means you see 1.95 after this and 2.05 before this, means the same function will also work here. 1.95 to 2.05, the functional value is here kx, right? Kx dx. The value of k you substitute it and you integrate it, and this you will get it 0.5. Coming to the last example, given a distribution function f of x is this, means here capital Fx is given, right? You have to find the density. You know what is fx? Fx is integral minus infinity to x fx dx. Now if it is fx is asked, then what will happen? It is d by dx of capital Fx, is not it, right? So this is the relation, I can say relation between small f and capital F, right? Relation between small f and capital F. So what is your small f now? So small f is, you just differentiate it. What is the derivative of this, right? The derivative of this is here 3e to the power minus 3x, x positive, and the derivative of 0 is 0 here. So this is my 0, x less than equal to 0. So this is my desired density function, is not it? So this is my desired density function. Next it is asked, also find x such that f of x is equal to 0.9. So next coming to this, it is your capital Fx, okay? Capital Fx, it is your capital Fx, means next coming to your capital f of x, capital F of x is 0.9, means you integrate from minus infinity to x, f dx is 0.9. Now it will valid from 0 to infinite, from 0 to x. What is the f? 3e to the power minus 3x dx is equal to 0.9. Just go on simplify it to solve. The value of x will be the value of, and you solve it to get 1 minus e to the power minus 3x is 0.9, and go on solving to find the value of x. Okay, the video is getting lengthy, so we should close here. Now coming to the summary, random variable are of two types. One is discrete random variable, other one is continuous random variable, right? Coming to the summary, random variable are of two types. One is discrete type, other one is continuous type. In discrete type, you have your probability mass function. In continuous type, you have your probability density function. And here, the distribution function is, this is your small fx and this is your small fx. And here the distribution function is capital F of x at x, means you add it up to x, right? It is p of xi, you add it up to x, and in this case capital F x of x, the distribution is from starting point minus infinity to x, you integrate it, okay? You integrate it. So this is the distribution. And what is the relation between f and f? As you know, capital F is the integration of small f, so your small f is the derivative of capital Fx. So this is the summary of the discussions, okay? So thank you all.